Good day. Today we are going to solve problems on simple, compound, reverse, vertical, parabolic, symmetric and asymmetric and spiral curves using arc and chord bases in the metric and English system. First, simple curves. A simple curve has a central angle of 36 degrees and a degree of curve of 6 degrees. A. Find nearest distance from the midpoint of the curve to the point of intersection of the tangents. B. Compute the distance from the midpoint of the curve to the midpoint of the long chord joining the point of curvature and point of tangency. C. If the stationing of the point of curvature is 10 and 020, compute the stationing of a point on the curve which intersects with a line making a deflection angle of 8 degrees with a tangent through the PC. Let's solve the problem using the arc basis in the metric system. To do so, we need to illustrate our problem and put the given in their corresponding spots. In the figure, 36 degrees is the central angle, 8 degrees is the deflection angle, and 18 degrees is I over 2. B represents the point which intersects with the line making a deflection angle with the tangent through the PC. So for A, we need to solve for the external distance or E. Before that, we need to solve first for the radius. Radius in arc basis is solved as 1145.916 divided by the degree of the curve. Substituting given values, we have r is equal to 190.986 meters. Since we now have the value of r, we can proceed in solving for E. E is equal to r multiplied by the difference between secant I over 2 and 1. It is equal to 190.986 multiplied by secant 18 degrees minus 1, resulting to E is equal to 9.829 meters. For B, we are to solve for the m, or the middle ordinate. It is equal to r multiplied by the difference between 1 and cosine I over 2. It is equal to 190.986 multiplied by 1 minus cosine 18 degrees. Thus, m is equal to 9.348 meters. Next, for C, first let's solve for S. And that is equal to Ri pi over 180 degrees, or in some formulas, it is 2Ri pi over 360 degrees. Substituting values, we have 190.986 multiplied by 16 degrees pi over 180. So S is 53.333 meters. Now, the stationing of B is simply the station of PC plus the value of S. So we have 10 and 020 plus 53.333, and the stationing of B is 10 and 073.333. Next, let's solve the same problem using chord bases, still in the metric system. So r in chord basis is solved as 10 over sine d over 2. So we have 10 over sine 6 degrees over 2 equals to 191.073 meters. Our E now is r multiplied by secant I over 2 minus 1. And that is 191.073 multiplied by secant 18 degrees minus 1, resulting to E is equal to 9.833 meters. For B, m is now r times 1 minus cosine I over 2 equals to 191.073 times 1 minus cosine 18 degrees. Thus, our m is 9.352 meters. Next, for C, our S is equal to Ri pi over 180 degrees equals to 191.073 multiplied by 16 degrees pi over 180 degrees. So S is equal to 53.358 meters. Finally, the stationing of B is equal to the sta of PC plus S. It is equal to 10 and 020 plus 53.358, resulting to our stationing of B 10 plus 073.358. Next, let's solve the same problem, this time using the English system of measurement. We will convert our given, and now our problem would be: a simple curve has a central angle of 36 degrees and a degree of curve of 6 degrees. A. Find the nearest distance from the midpoint of the curve to the point of intersection of the tangents. B. Compute the distance from the midpoint of the curve to the midpoint of the long chord joining the point of curvature and point of tangency. C. If the stationing of the point of curvature is 1 and 2, compute the stationing of a point on the curve which intersects with the line, making a deflection angle of 8 degrees with a tangent through the PC. Let's solve the problem using arc basis. Our figure would look like this, roughly the same as before, but the values are in English system. Solving for r is equal to 5,729.578 over d. It is equal to 5,729.578 over 6 degrees, equaling to 954.930 feet. Our e would be r multiplied by secant I over 2 minus 1. It is equals to 954.930 multiplied by secant 18 degrees minus 1. So E is equal to 49.143 feet. M is equal to R multiplied by 1 minus cosine I over 2. It is equal to 954.930 multiplied by 1 minus cosine 18 degrees. So our M is 46.738 feet. Our S is r I pi over 180. It is equal to 954.930 multiplied by 16 degrees r pi over 180. Thus, S is equal to 266.667 feet. Finally, the stationing of B is equal to the sum of the stationing of PC and S. So 1 and 2 plus 266.667, the stationing of B is equal to 3 and 68.667. Next, let's solve the problem using chord basis, still in the English system. Our figure would roughly remain the same. R now is equal to 50 over sine d over 2. It is equal to 50 over sine 6 degrees over 2, so R is 955.366 feet. E is equal to R multiplied by secant I over 2 minus 1. It is equal to 955.366 multiplied by secant 18 degrees minus 1. So E is equal to 49.165 feet. Our middle ordinate, or M, is R multiplied by 1 minus cosine I over 2. It is equal to 955.366 multiplied by 1 minus cosine 18 degrees. Thus, M is equal to 46.759 feet. Next, S is equal to Ri pi over 180 degrees equals to 955.366 times 16 degrees pi over 180 degrees. So the value of S is equal to 266.789 feet. Therefore, the stationing of B would be the sum of the stationing of PC and S. We have 1 plus 002 plus 266.789, resulting to the stationing of B 3 and 68.789. Next, let's proceed to compound curves. Given a compound curve, I sub 1 is equal to 24 degrees, I sub 2 is equal to 36 degrees, d sub 1 6 degrees, and d sub 2 4 degrees. A. Compute the length of the common tangent of the curve. B. Compute the stationing of PCC if PC is at 10 and 420. C. Compute the stationing of the PT. First, using arc basis in the metric system. Based on the given, our figure would look like this. PC is the point of curvature, PT the point of tangency, and the sum of T1 and T2 is the length of our common tangent. For A, we need to solve for the length of the common tangent, but before that, we first need to determine the value of our radius. Using arc basis, r is equal to 1145.916 over d, or the degree of the curve. So r1 is equal to 1145.916 over 6 degrees. r1 is equal to 190.986 meters, while r2 is equal to 1145.916 divided by 4 degrees. It is equal to 286.479 meters. Since we already have the value of r1 and r2, we can now solve for the value of t. So t is equal to r1 tangent I1 over 2 plus r2 tangent I2 over 2, and that will be 190.986 tangent 12 degrees plus 286.479 tangent 18 degrees. So the length of our common tangent, or t, is equal to 133.678 meters. For B, we first need to determine the value of L. In the metric system, L is equal to 20 I sub 1 over T sub 1. It is equal to 20 multiplied by 24 degrees over 6 degrees. So L sub 1 is equal to 80 meters. The stationing of the PCC is the sum of the stationing of PC and L sub 1. So we have 10 and 420 plus 80 meters. So the stationing of the PCC is equal to 10 and 500. Next, our L sub 2 is equal to 20I sub 2 over D2. It is equal to 20 multiplied by 36 degrees over 4 degrees. Thus, L sub 2 is equal to 180 meters. The stationing of the PT is the sum of the stationing of PCC and L sub 2. So 10 and 500 plus 180 meters, our stationing of PT is equal to 10 and 680. Now let's solve the problem using chord basis still in the metric system. Using the same figure as before, R would be 10 over sine D sub 1 over 2. It is equal to 10 over sine 6 degrees over 2. Thus, our R sub 1 is equal to 191.073 meters. Our R sub 2, using the same equation, we have 10 over sine 4 degrees over 2, resulting to R sub 2 is equal to 286.537 meters. T is equal to R sub 1 tangent I sub 1 over 2 plus R2 tangent I sub 2 over 2. It is equal to 191.073 tangent 12 degrees plus 286.537 tangent 18 degrees. So the length of our common tangent, or T, is equal to 133.715 meters. For B, the formula for L is equal to 20I over D. Substituting values, we have 20 multiplied by 24 degrees over 6 degrees. L is equal to 80 meters. The stationing of the PCC is the sum of the stationing of PC and L1. It is equal to 10 and 420 plus 80 meters. The stationing of PCC is equal to 10 and 500. Next, our L sub 2. Using the same formula, we have 20 multiplied by 36 degrees over 4 degrees. L sub 2 is equal to 180 meters. Now, the stationing of the PT is equal to the stationing of PCC plus the L2. It is equal to 10 and 500 plus 180 meters. Stationing of PT is equal to 10 and 680. Next, let's solve the same problem using the English system. So our problem now would be, given the compound curve I sub 1, 24 degrees, I sub 2, 36 degrees, V sub 1, 6 degrees, and D sub 2, 4 degrees. A. Compute the length of the common tangent of the curve. B. Compute the stationing of PCC if PC is at 1 and 42. C. Compute the stationing of the PT. First, using the arc basis. R sub 1 is equal to 5,729.578 over T. It is equal to 5,729.578 over 6 degrees. Our R sub 1 is now equal to 954.930 feet. In R2, using the same formula, we have 5,729.578 over 4 degrees. So R sub 2 is equal to 1,432.395 feet. T is equal to R tangent I over 2. Substituting the values for R sub 1 and R sub 2, the length of our common tangent would now be equal to 668.390 feet. L is equal to 100 I over T. So for L sub 1, we have 100 multiplied by 24 degrees divided by 6 degrees. L sub 1 is equal to 400 feet. Now the stationing of PCC would be the sum of stationing of PC plus the L sub 1. We have 1 and 42 plus 400 feet, so the stationing of PCC is 5 and 42. Using the same formula for L, our L sub 2 would now be 100 multiplied by 36 degrees divided by 4 degrees. Thus, our L sub 2 is now 900 feet. For the stationing of PT, it is simply stationing of PCC plus the value of L sub 2. So we have 5 and 42 plus 900 feet. The stationing of PT is 14 and 42. Now let's solve the problem using the chord basis still in the English system of measurement. Using the same figure and values, our R would be 50 over sine D over 2. So our R sub 1 is computed as 50 over sine 6 degrees over 2, resulting to 955.366 feet. Using the same formula for R sub 2, our R sub 2 would now be equal to 1,432.685 feet. Our T would be computed as the same as before. Substituting values, we have 955.366 tangent 12 degrees plus 1,432.685 tangent 18 degrees. Our T is equal to 668.577 feet. For L, we have 100 multiplied by I over T. For L sub 1, we have 100 multiplied by 24 degrees over 6 degrees. L sub 1 is 400 feet. The stationing of PCC is the sum of stationing of PC plus L sub 1. We have 1 and 42 plus 400 feet. So the stationing of PCC is equal to 5 and 42. For L sub 2, using the same formulas, we have 100 multiplied by 36 degrees divided by 4 degrees. our L sub 2 would result to 900 feet. For the stationing of PT, we simply need to add the stationing of PCC and the value of L sub 2. That is equal to 5 and 42 plus 900 feet. So the stationing of PT is equal to 14 and 42. Now let's move to reversed curves. A reverse curve connects two converging tangents intersecting at an angle of 30 degrees. The distance of this intersection from the PI of the curve is 150 meters. The deflection angle of the common tangent from the back tangent is 20 degrees, and the azimuth of the common tangent is 320 degrees. The degree of the curve of the second simple curve is 6 degrees, and the stationing of the point of intersection of the first curve is 4 and 450. A. Determine the radius of the first curve. B. Determine the stationing of the PRC. And C. Determine the stationing of the PT. So, solving the problem in arc basis using the metric system first. From the given values, our figure would roughly look like this. The PC is the point of curvature. PI is the point of intersection, with its stationing at 4 and 450. From the figure, we can roughly see a triangle looking like this with points ABC. First, we need to solve for the length of AB. Using sine law, we have AB over sine 30 degrees equals to 150 over sine 20 degrees. Solving the equation, we have the length of AB equaling to 219.285 meters. Next, based on our figure, T sub 1 and T sub 2 should be equal to the length of AB, which is 219.285. But T sub 1 is equal to R sub 1 tangent I sub 1 over 2, and T sub 2 is equal to R sub 2 tangent I sub 2 over 2. Before proceeding to that, we need to solve first for the value of I sub 1. So I sub 2 is equal to the sum of I sub 1 plus 30 degrees. Substituting our known values, we can now find I sub 1, which is equal to 20 degrees. Our radius now in arc basis would be computed as 1145.916 over the degree of the curve. Substituting the values, we have 1145.916 over 6 degrees. So our R sub 2 is equal to 190.986 meters. So from the earlier equation, we have T sub 1 plus T sub 2 is equal to AP. But T sub 1 is equal to R1 tangent I1 over 2, and T sub 2 is equal to R2 tangent I2 over 2, while the length of AB is 219.285. Substituting the values that we have, it will now be equal to R sub 1 tangent 10 degrees plus R sub 2 tangent 25 degrees equaling to 219.285. We have R sub 1 tangent 10 degrees plus 190.986 tangent 25 degrees equals to 219.285. Solving the equation, we have R sub 1 would be equal to 738.554 meters. Next, for B, we need to solve for the stationing of the PRC. But before that, let's first solve for the degree of the curve for the first curve. So the equation would be equal to T sub 1 is equal to 1145.916 divided by R sub 1. It is now equal to 1145.916 over 738.554. So d sub 1 is equal to 1.552 degrees. Next, d sub 1 now would be equal to r sub 1 tangent I sub 1 over 2. Substituting values, we have 738.554 tangent 20 degrees over 2, resulting to 130.227 meters. Next, the stationing of the PC is equal to 4 and 450 minus 130.227. The stationing of the PC is equal to 4 and 519.773. L1 would be equal to 20 multiplied by 20 degrees over 1.552. So the value of our L sub 1 is equal to 257.732 meters. Now that we have the values of the stationing of the PC and the value of L sub 1, we can now proceed in solving the stationing of the PRC. So stationing of PRC is equal to the sum of stationing of PC plus L sub 1. It is equal to 4 and 319.773 plus 257.732. Thus, the stationing of PRC is equal to 4 and 577.505. Next, solving for the stationing of the PT. So let's first solve for the value of L sub 2. It is equal to 20 multiplied by 50 degrees over 6. So the value of L sub 2 is 166.667 meters. So the stationing of PT is simply the sum of the stationing of PRC plus the value of L sub 2. Substituting values, we have 4 and 577.505 plus 166.667 meters. Thus, the stationing of PT is equal to 4 and 744.172. Next, let's solve the same problem, but this time using the chord basis, still in the metric system. So using the same figure and the same process, we have AB over sine 30 degrees equals to 150 over sine 20 degrees. The length of our AB is equal to 219.285 meters. I sub 1 is 50 degrees minus 30 degrees equaling to 20 degrees. Our radius in chord basis would be computed as 10 divided by sine d sub 2 over 2. Substituting values, we have 10 divided by sine 6 degrees over 2. So the value of our r sub 2 is equal to 191.073 meters. We have t sub 1 plus t sub 2 is equal to 219.285. But t sub 1 is equal to r sub 1 tangent I sub 1 over 2, while t sub 2 is equal to r sub 2 tangent I sub 2 over 2. Substituting node values, we have r sub 1 tangent 10 degrees plus 191.073 tangent 25 degrees equals to 219.285. Solving the equation, the value of our r sub 1 is equal to 739.693 meters. The degree of the curve in chord basis would be computed as 2 arc sine 10 over r sub 1. It is equal to 2 arc sine 10 divided by 739.693. Thus, d sub 1 is equal to 1.549 degrees. Our t sub 1 would be computed as r sub 1 tangent I sub 1 over 2. It is equal to 739.693 tangent 20 degrees divided by 2. So our t sub 1 is equal to 130.428 meters. The stationing of the PT is the difference between 4 and 450 minus 130.428. So the stationing of PT would now be equal to 4 and 319.572. Next, our L sub 1 would be computed as 20 multiplied by I sub 1 divided by D sub 1. We have 20 multiplied by 20 degrees divided by 1.549 degrees. So our L sub 1 would be equal to 258.231 meters. Next, the stationing of the PRC would be equal to the sum of 4 and 319.572 and the value of L sub 1, which is 258.231. Thus, the stationing of PRC would be equal to 4 and 577.803. Next, the value of L sub 2 would be computed as 20 multiplied by 50 degrees divided by 6 degrees, equaling to our L sub 2, 166.667 meters. So the stationing of the PT would now be the sum between the stationing of PRC and the value of L sub 2. It would be 4 and 577.803 plus 166.667. So the stationing of PT would be equal to 4 and 744.470. Next, let's solve the same problem, but this time using the English system of measurement. So, converting the values into the English system, our problem would be read as: a reverse curve connects two converging tangents intersecting at an angle of 30 degrees. The distance of this intersection from the PI of the curve is 492.126 feet. The deflection angle of the common tangent from the back tangent is 20 degrees, and the azimuth of the common tangent is 320 degrees. The degree of curve of the second simple curve is 6 degrees, and the stationing of the point of intersection of the first curve is 4 and 45. A. Determine the radius of the first curve. B. Determine the stationing of the PRC. And C. Determine the stationing of the PT. First, let's solve the problem using the arc basis. So our figure would roughly remain the same, but 150 meters would now be 492.126 feet, while the stationing would now be 4 and 45. From the figure, we have a triangle that looks like this, with points A, B, and C, and the length of BC as 492.126 feet. So solving for the length of AB using the sine law, we have AB over sine 30 degrees is equal to 492.126 over sine 20 degrees. Solving the equation, we have the length of AB as 719.440 feet. Our I sub 1 would be solved as the same as before, which is 50 degrees minus 30 degrees. So our I sub 1 is equal to 20 degrees. Our radius and arc basis and the English system would be computed as 5,729.578 divided by the degree of the curve, which is 6 degrees. So our R sub 2 would now be equal to 954.930 feet. Next, in solving for R sub 1, we will use this formula. t sub 1 plus t sub 2 is equal to the length of AB. Substituting the values, we have r sub 1 tangent 10 degrees plus 954.930 tangent 25 degrees equals to 719.440. Solving the equation, we have r sub 1 is equal to 1,557.665 feet. Next, the value of the degree of the curve in the English system would be computed as 529.578 over r sub 1. Substituting values, we have 5,729.578 over 1,557.665. The degree of the first curve would now be equal to 3.678 degrees. Our t sub 1 is equal to r sub 1 tangent I sub 1 over 2. Substituting values, we have 1,557.665 tangent 20 degrees over 2. So our t sub 1 would now be equal to 274.658 feet. Next, the stationing of the PC would be equal to 4 and 45 minus 274.658. Thus, the stationing of PC is equal to 1 and 70.342. Next, in the English system, L would be computed as 100 I over D. Substituting values, our L sub 1 would now be equal to 543.774 feet. The value of the stationing of the PRC is simply the stationing of PC plus the value of L sub 1. So it is 1 and 70.342 plus 543.774. The stationing of PRC would now be equal to 7 and 14.116. Next, L sub 2, using the same formula, we have 100 multiplied by 50 degrees over 6 degrees. The value of our L sub 2 is equal to 833.333 feet. The stationing of PT is simply the sum of the stationing of PRC and the value of our L sub 2. So it is 7 and 14.116 plus 833.333 feet. Thus, the stationing of the PT is equal to 15 and 47.449. Now, let's solve the same problem, but this time using the chord basis. So we're still in the English system of measurement. Our figure would remain the same, and the triangle is still like this. So using sine law as before, the length of our AB would now be equal to 719.440 feet. Our I sub 1 would be equal to 20 degrees. And our radius in chord basis would be computed as 50 divided by sine d over 2. Substituting values, we have 50 over sine 6 degrees over 2. Thus, the value of our r sub 2 is 955.366 feet. Solving for r1, we have t sub 1 plus t sub 2 is equal to the length of AB. It is equal to r sub 1 tangent 10 degrees plus 955.366 tangent 25 degrees is equal to 719.440. Solving the equation, the value of our r sub 1 would be equal to 1,556.511 feet. Next, the degree of the curve would be computed as 2 arc sine 50 over r. Substituting values, we have 2 arc sine 50 over 1556.511. So our d sub 1 is equal to 3.682 degrees. Our d sub 1 is equal to r sub 1 tangent I sub 1 over 2. Substituting values, our t sub 1 would now be equal to 274.455 feet. Next, solving for the stationing of the PC. It is equal to 4 and 45 minus 274.455. So the stationing of PC is equal to 1 and 70.545. Next, for the value of L sub 1, it will be computed as 100 multiplied by I sub 1 over D sub 1. It would be 100 multiplied by 20 degrees over 3.682 degrees. So the value of L sub 1 would now be equal to 543.183 feet. The stationing of the PRC, like before, is the sum of the PC plus the value of L sub 1. So the stationing of PRC would now be equal to 7 and 13.728. Next, our L sub 2 using the same formulas and substituting the given values, it would now be equal to 833.333 feet. So solving for the stationing of the PT, it is equal to the stationing of PRC plus the value of L sub 2. It is 7 and 13.728 plus 833.333. So the stationing of PT is equal to 15 and 47.061. Next, let's solve a problem in the vertical parabolic curve. Unlike before, instead of arc and chord basis, we'll use symmetric and asymmetric, but we'll still solve using the metric and English system of measurement. First, for symmetric parabolic curve, a vertical summit has its highest point of the curve at a distance 48 meters from the PT. The back tangent has a grade of positive 6% and a forward grade of negative 4%. The curve passes through point A on the curve at station 25 and 140. The elevation of the grade intersections is 100 meters at station 25 and 160. A. Compute the length of the curve. B. Compute the stationing of PT. And C. Compute the elevation of point A on the curve. So let's solve using the metric system first. From the problem, our figure would look like this, with G sub 1 and G sub 2 representing the back and forward tangent respectively. S sub 2 is the distance between the highest point of the curve and the point of tangent C or PT. For A, using the formula, we have S sub 2 is equal to G sub 2 multiplied by L divided by G sub 2 minus G sub 1. Substituting values, the equation would be 48 is equal to negative 0.04 L divided by negative 0.04 minus 0.06. So the length of the curve is equal to 120 meters. For B, the stationing of PT is simply 25 and 160 plus L divided by 2. So we have 25 and 160 plus 120 over 2. It is 60. So the stationing of our PT is 25 and 220. Next, for C, before we can solve for the elevation of A, we need to find first the values of Y and H. First, the value of h would be computed as L over 8 multiplied by g sub 2 minus g sub 1. It is equal to 120 over 8 multiplied by 0.06 minus negative 0.04. Thus, h is equal to 1.5 meters. Next, the value of y. It would be computed as y over 40 square, which is L over 2 divided by the value of h, is equal to h, which is 1.5 over L over 2 square, which is 60. So solving the equation, we have y is equal to 0.67. Now that we have the values of y and h, we can now compute for the value of the elevation of A. So elevation of A is simply 100, which is the elevation of the grade intersections, minus 20, which is 60 minus 40, multiplied by 0.06 minus the value of y, which is 0.67. Thus, the elevation of point A is 98.130 meters. Now, let's solve the problem using the English system. Converting given values, our problem would now be: a vertical summit has its highest point of the curve at the distance 157.480 feet from the PT. The back tangent has a grade of positive 6% and a forward grade of negative 4%. The curve passes through point A on the curve at station 25 and 14. The elevation of the grade intersections is 328.084 feet at station 25 and 16. A. Compute the length of the curve. B. Compute the stationing of PT. And C. Compute the elevation of point A on the curve. So using the same figure but with the values being in the English system, the elevation would now be 328.084 feet instead of 100 meters. S sub 2 would now be 157.480 feet instead of 48 meters. So the stationing 25 and 140 would now be 25 and 14. So for A, we need to find for the length of the curve. Using the same formula as before, it is S sub 2 equals to G sub 2L over G sub 2 minus G sub 1. Substituting values, we have 157.480 is equal to negative 0.04L over negative 0.04 minus 0.06. So now our L would be 393.700 feet. Next, the stationing of the PT is equal to 25 and 16 plus L over 2. We have 25 and 16 plus 196.850. The stationing of the PT now would be 27 and 12.850. So for C, like before, we need to find first the values of h and y. So for h, it is L over 8 multiplied by G sub 2 minus G sub 1. Substituting values, we have 393.700 over 8 multiplied by 0.06 minus negative 0.04. So the value of our h would be 4.921. Next, solving for the value of y. We have y over 156.848 squared. So 156.848 comes from L over 2 divided by the value of h. It is equal to the value of h, which is 4.921 over 196.850 square. 196.850 is L over 2. So solving the equation, we have the value of y equaling to 3.124. Now that we have the values of y and h, we can now solve for the elevation of point A. So it is simply 328.084 minus 40.002 multiplied by 0.06 minus 3.124. So 328.084 is the elevation of the grade intersections, while 40.002 is simply L over 2 minus 156.848. 0.06 is the grade of the back tangent, while 3.124 is the value of our y. So solving the equation, the elevation of point A is equal to 322.560 feet. Next, let's solve a vertical asymmetric parabolic curve. A forward tangent of positive 6% was designed to intersect a back tangent of negative 3% at the proposed underpass along Epifanio de los Santos Avenue, so as to maintain a minimum clearance allowed under a bridge which crosses perpendicular to the underpass. A through 100-meter curve lies on the side of the back tangent, while a 100-meter curve lies on the side of the forward tangent. The stationing and elevation of the grade intersection is 12 and 530.20 and 100 meters respectively. The center line of the bridge falls at station 12 and 575.20. The elevation of the underside of the bridge is 117.48 meters. A. Determine the clearance of the bridge at the left side if it has a width of 10 meters. B. Determine the clearance of the bridge at the right side. And C. Determine the clearance at the bridge at the center of the bridge. So first, let's solve the problem using the metric system of measurement. So from the given values, our illustration would look like this. X sub 2 is half of L sub 2, while X sub 1 is simply X sub 2 plus the width of the bridge. 45 meters is what's left if we add half the width of the bridge in X sub 2 and subtracting the resulting value from L sub 2. So it's 100 minus 50 plus 5 equals to 45 meters. So for A, we need to find the clearance on the left side of the bridge. But before we can solve for that, a lot of missing data should be solved first. We need to find values of H and Y sub 1, Y sub 2, elevation of A and elevation of B. So using the triangle extracted from our illustration, we have 2H over L sub 1 equals to L sub 2 multiplied by G sub 2 minus G sub 1 divided by L sub 1 plus L sub 2. Simplifying our equation, it would be H is equal to L sub 1 L sub 2 multiplied by G sub 2 minus G sub 1 divided by twice the sum of L sub 1 and L sub 2. Substituting the values that we have, it will be 200 multiplied by 100 times 0.06 minus 0.03 divided by twice the sum of 200 and 100. Solving the equation, we have H is equal to 3 meters. Now that we have the value of H, we can now solve for Y sub 1 and Y sub 2. So Y sub 1 over X sub 1 squared is equal to H over L sub 2 squared. Substituting values, we have Y sub 1 over 60 squared is equal to 3 over 100 squared. Solving the equation, y sub 1 would be equal to 1.080 meters. Next, using the same process, we can solve for y sub 2. Y sub 2 would be y sub 2 over Now that we have the needed values, we can now proceed in solving for the clearance on the left side of the bridge. So in solving that, we just need to subtract the elevation of B from the elevation of the underside of the bridge. So it is 117.480 minus 103.480. Thus, the clearance on the left side of the bridge is equal to 14 meters. Next, let's solve for the clearance at the right side of the bridge. But before that, let's first solve for the elevation of C and the elevation of D. So elevation of C is simply 100 plus 0.06 multiplied by 50. Solving that, we have the elevation of C equaling to 103 meters. Next, the elevation of D is simply elevation of C plus the value of y sub 2. It is 103 plus 0.750. Thus, the elevation of D is equal to 103.750 meters. Now that we have the value needed, we can now solve for the clearance on the right side of the bridge. So the clearance on the right side of the bridge is simply elevation of D subtracted from the elevation on the underside of the bridge. So it is 117.48 minus 103.750. Thus, the clearance on the right side of the bridge is 13.730 meters. Next, for C, we need to solve for the clearance at the center of the bridge. But we first need to solve for y sub 3 and the elevation of E. So first, for y sub 3, using the same process as solving for y sub 1 and y sub 2, we have y sub 3 over 55 square is equal to 3 over 100 square. Solving the equation, we have y sub 3 equaling to 0.908 meters. Next, the elevation of E is simply 100 plus 45 times 0.06 plus the value of y sub 3, which is equal to 0.908. Solving the equation, the elevation of E would now be equal to 103.608. Now we can proceed in solving for the clearance at the center of the bridge. Like before, the clearance at the center is simply the elevation of E subtracted from the elevation of the underside of the bridge. So it is 117.48 minus 103.608. So the clearance at the center of the bridge is equal to 13.872 meters. Next, let's solve the same problem, but this time using the English system of measurement. So converting the values into the English system, our problem would be a forward tangent of positive 6% was designed to intersect a back tangent of negative 3% at the proposed underpass along Epifanio de los Santos Avenue so as to maintain a minimum clearance allowed under a bridge which crosses perpendicular to the underpass. A 656.170 feet curve lies on the side of the back tangent, while a 328.084 feet curve lies on the side of the forward tangent. The stationing and elevation of the great intersection is 12 and 53.020 and 328.084 3.084 feet respectively. The center line of the bridge falls at station 1257.520. The elevation of the underside of the bridge is 385.433 feet. A. Determine the clearance of the bridge at the left side if it has a width of 32.808 feet. B. Determine the clearance of the bridge at the right side. And C. Determine the clearance at the bridge at the center of the bridge. So solving the problem in the English system of measurement, our illustration would look like this. So it roughly remained the same, but the values would now be in the English system. So instead of 55 meters, we have 180.446 feet. Instead of x sub 1 being 60 meters, we now have 196.850 feet. Instead of x sub 2 being 50 meters, we now have 164.042 feet. And instead of our L sub 1 being 200 meters and L sub 2 being 100 meters, we now have the L sub 1 as 656.170 feet, while the L sub 2 would now be 328.084 feet, while the elevation of the underside of the bridge would now be 385.433 feet. So for A, using the same process as before, we also need to solve for the value of h, y sub 1, y sub 2, y sub 3, and the elevations of A, B, C, D, and E. So first, let's solve for the value of h. So it is equal to L1 L2 multiplied by G sub 2 minus G sub 1 divided by twice the sum of L sub 1 and L sub 2. Substituting the given values, we have 656.170 times 328.084 times 0.06 minus 0.03 divided by twice the sum of 656.170 and 328.084. Solving the equation, we have the value of h at 3.281 feet. Next, for value of y sub 1. Like before, it is y sub 1 over x sub 1 square equals to h over L sub 2 square. We have y sub 1 over 196.850 square equals to 3.281 over 328.084 square. Solving the equation, the value of y sub 1 is 1.181 feet. Next, with the same equation, let's solve for the y sub 2. Substituting values, our y sub 2 would now be equal to 0.820. So for the elevation of A, it is equal to 328.084 plus 0.06 multiplied by 131.234. Thus, the elevation of our A would now be equal to 335.958 feet. Well, the elevation of B is simply the elevation of A plus the value of our y sub 1. So we have 335.958 plus 1.181. Thus, the elevation of B is now 337.139 feet. Now that we have the values needed, we can now solve for the clearance on the left side of the bridge. Like before in the metric system, the clearance on the left side is simply the elevation of B subtracted from the elevation on the underside of the bridge. So we have 385.433 minus 337.139. Thus, the clearance on the left side of the bridge is now 48.294 feet. Next, for the clearance on the right side of the bridge, simply need to solve first for the elevation of C and the elevation of D. So the elevation of C is equal to 328.084 plus 0.06 multiplied by 164.042. Solving the equation, the elevation of C would now be equal to 337.927 feet. So next, the elevation of D is simply the elevation of C plus the value of y sub 2. So we have 337.927 plus 0.820. Elevation of D would now be equal to 338.747 feet. Next is the clearance on the right side of the bridge. So it is simply the elevation of D minus the elevation on the underside of the bridge. So it is 385.433 minus 338.747. So the clearance at the right side of the bridge would be 46.685 feet. Next, for C, we need to find for the clearance at the center of the bridge. So to do that, we need to solve first for y sub 3 and the value of the elevation of E. So like before, y sub 3 over 180.446 square equals to 3.281 over 328.084 square. Solving the equation, the value of y sub 3 is equal to 0.993. Now the value of elevation of E is computed as 328.084 plus 147.638 times 0.06 plus 0.993. Solving that, the elevation of E would result to 337.935 feet. Now that we have the value of elevation of E, we just need to subtract that from the underside of the bridge to get the clearance at the center of the bridge. So it is 385.433 minus 337.935. So the value at the clearance at the center of the bridge is equal to 47.498 feet. Now for the final part, let's solve a problem on spiral curves. The central curve of an easement curve is on a 5-degree curve. Spiral easement curve has a length of throw equal to 1.02 meters at TS. A. Compute the required length of the spiral curve. B. Determine the velocity of the car passing through this curve so that it will not exceed the minimum centrifugal acceleration of 0.50 meters per second. C. What is the length of the long tangent of a spiral easement curve if the distance along the tangent up to SC is 73.60 meters long? So like before, let's solve it first using arc basis in the metric system. So for A, we need to find the required length of the spiral curve. But we need the value of R in our formula. So let's solve that first. R in the arc metric is computed as 1145.916 over D. So we have 1145.916 over 5 degrees. Thus, the value of R is 229.183 meters. Since we now have the value of R, we can now solve for L. Using the formula P is equal to L squared over 24R and substituting the values, we have 1.02 is equal to L squared over 24 multiplied by 229.183. So our L is equal to 74.903 meters. Next, for B, we'll need to solve for the velocity. Since we already have the L and R at hand, let's use the formula L is equal to 0.0215 v cubed over c multiplied by R. L is equal to 74.903, c is 0.15 meters per second, while R is 229.183. Solving the equation, the velocity would be equal to 73.633 kilometers per hour. Next, for c, we are to determine the length of the long tangent. From the given, we can use this illustration as the reference. So based on this figure, we can find the length of the long tangent if we subtract the value of h from 73.60 meters. So let's determine first the value of h. But to do that, we need to first determine the value of the spiral angle, or the S sub c, and the offset distance, or the x sub c. So S sub c is computed as L over 2R multiplied by 180 over pi. Substituting values, we have 74.903 divided by 2 times 229.183 multiplied by 180 over pi. Solving the equation, our spiral angle would now be equal to 9 degrees 21 minutes. Next, the offset distance, or x sub c, is simply 4 multiplied by the length of throw, or p, which is 1.02. Solving that, the value of our x sub c is equal to 4.08 meters. Now we can finally look for the value of h. Using the formula tangent S sub c is equal to x sub c over h. We have tangent 9 degrees 21 meters equaling to 4.08 over h. Solving the equation, the value of h is now equal to 24.779 meters. Now that we have the value of h, we just subtract that from 73.60 meters to get the value of the long tangent. So 73.60 minus 24.779 is 48.821 meters. Next, let's solve the same problem, but this time using the chord basis, still in the metric system of measurement. Using the same process as before, we first need to solve for the radius, but in chord basis, radius is computed as 10 divided by sine t over 2. Substituting values, we have 10 divided by sine 5 degrees over 2, resulting to r being 229.256 meters. Next, for the length of the spiral curve, using the same formula as before, we have P is equal to L squared over 24R. We have 1.02 equals to L squared over 24 multiplied by 229.256. Thus, the required length of the spiral curve is equal to 74.915 meters. Next, for the velocity, we'll use the same formula. We have L is equal to 0.0215 v cubed over c multiplied by r. Substituting the values, we have 74.915 equals to 0.0215 v cubed divided by 0.15 multiplied by 229.256. Solving the equation, the velocity would now be equal to 73.645 kilometers per hour. Next, for c, we are to determine again the length of the long tangent. So like before, we need to find the value of h. So from the figure, h is needed since we just need to subtract the value of h from 73.60 meters to get the value of the long tangent. So using the same process, let's solve first for the spiral angle and the offset distance. So spiral angle is equal to L over 2R multiplied by 180 degrees over pi. Substituting values, we have 74.915 divided by 2 multiplied by 229.256 times 180 degrees over pi. So the value of the spiral angle is equal to 9 degrees 21 minutes. X is simply 4 multiplied by the length of throw, which is 1.02. Thus, the offset distance is 4.08 meters. For solving the value of h using the same formula, we have tangent 9 degrees 21 minutes is equal to x over h. Solving the equation, the length of h would now be equal to 24.779 meters. So subtracting the value of h from 73.60 meters, the length of the long tangent is equal to 48.821 meters. Next, let's solve the same problem but this time in the English system of measurement. So converting the given values in English system, our problem would be read as: the central curve of an easement curve is on a 5-degree curve. Spiral easement curve has a length of throw equal to 3.346 feet at the TS. A. Compute the required length of the spiral curve. B. Determine the velocity of the car passing through this curve so that it will not exceed the minimum centrifugal acceleration of 1.640 feet per second. C. What is the length of the long tangent of a spiral easement curve if the distance along the tangent up to SC is 241.470 feet long? So let's solve the problem first in the arc basis. Using the same process in the metric system, we need to first solve for the value of r. But in the arc English system, r is computed as 5,729.578 over d. Substituting values, it is 5,729.578 over 5 degrees. So the value of r now would be 1,145.916 feet. Next, the value of the required length of the spiral curve. So we have P is equal to L squared over 24R. Substituting the given values, we have 3.346 equals to L squared over 24 multiplied by 1,145.916. Solving the equation, the required length is now equal to 303.351 feet. For B, like before, we need to solve for the velocity. Using the same formula, we have L is equal to 0.0215 v cubed divided by c times r. Substituting values and solving the equation, our velocity would now be equal to 298.196 miles per hour. Next, for C, we need to solve for the length of the long tangent. So like before, we need to solve first for the spiral angle, the offset distance, and the length of h. So S would be computed the same as before, which is L over 2R multiplied by 180 degrees over pi. Substituting values, we have 303.351 over 2 times 1145.916 multiplied by 180 degrees over pi. Solving the equation, the spiral angle would now be equal to 7 degrees 35 minutes. XC, or the offset distance, is simply 4 multiplied by the length of throw. So that is 4 multiplied by 3.346 feet. So it will be equal to 13.384. So solving for h, we have tangent 7 degrees 35 minutes is equal to 13.384 over h. Solving the equation, the value of h now would be 100.531 feet. So for the length of the long tangent, we just need to subtract the value of h from the given 241.740. So the length of our long tangent would now be equal to 141.209 feet. Next, let's solve the problem still in the English system, but now using chord basis. So the process would remain the same, but in a chord basis and English system, the radius would be computed as 50 divided by sine d over 2. So we have 50 over sine 5 degrees over 2, resulting to our radius being 1146.279 feet. The required length would now be computed as P is equal to L squared over 24R. Substituting values and solving the equation, the required length now would be 303.399 feet. For B, we need to solve for the velocity. Using the same formula as before and substituting the given values, we have 303.399 is equal to 0.0215 v cubed over 1.640 multiplied by 1146.279. Thus, the velocity would now be equal to 298.243 miles per hour. Next, for letter C, we need to find the length of the long tangent, but we need to first determine the value of the spiral angle, the value of the offset distance, and the value of h. Solving for the spiral angle is equal to L over 2R multiplied by 180 degrees over pi. Substituting values, we have 303.399 over 2 multiplied by 1146.279 times 180 degrees over pi. Thus, the value of our spiral angle would now be 7 degrees 35 minutes. Next, tangent 7 degrees 35 minutes is equal to xc, which is 4 multiplied by the length of throw, equaling to 13.384 over h. The value of h now would be 100.531 feet. Lastly, for the length of the long tangent, we have 241.740 minus the value of h, which is 100.531. Thus, the length of the long tangent is equal to 141.209 feet. Good day. Today we are going to solve